Greetings, we are Team JCO 001 presenting on our study optimized table. We have identified some prominent issues within the work environment that hinder the user's ability to perform. We hope to tackle these issues with our design. So what are our solutions to this problem? Firstly, the table needs to be adjustable. This allows for personalization of the table for the user's needs, as well as protecting their eyes and posture. Secondly, light sources will be incorporated into the table design to provide a bright work environment to protect the eyes. Thirdly, we have designed a phone exclusion zone, which will follow the user's timetable and prevent them from picking up their phone while they are studying. Here are some experiments we conducted. This experiment was conducted with the user's comfort in mind, with respect to the table height. These are the results for person A. And here are the results for person B. From the results here, we can see that for individuals with average height, the ideal table height is around 75 to 85 centimeters. We also conducted another experiment with posture in mind, this time with respect to the table height. Here are the results. And here are the results for person B. You can see that, again, the ideal height of tables to maintain a good posture is around 75 to 85 centimeters. Since there are two test variables, they should not serve as a generalization of the experiment for individuals.
We have found this research paper to prove that sloped tabletops are more comfortable for users. The methodology is as stated. So these are the muscles measured. And with this in mind, let us analyze the results. Here we can see that generally the most comfortable variable will be 85 centimeters at 20 degrees, as it has the overall highest percentage MBC. There are some simpler results, again with 85 centimeters at 20 degrees, providing the most comfort for the user's neck. This will be taken into consideration in our table design. This research paper led us to consider the ability for the table to turn into a standing one at the choice of the user. The potential advantages and disadvantages can be seen from the result. The methodology is as follows. Here are the results, which we will explain. Firstly, similar postures in both groups at the start show that the results will be consistent. Secondly, standing desk allows for improved posture and sitting desk leads to worsened posture. Thirdly, and also counterintuitively, the standing desk did not cause discomfort and tiredness. With this in mind, let's proceed. This other research paper serves to tell us how big of a distraction phones can be in our everyday lives. The methodology is as follows, and the results are on the following slide. So indeed, excessive phone usage does harm to our grades. At the end, we have taken all the above issues into consideration when designing our table.
The finalized table design. This is the base table. It will have a base height of 80 centimeters and a max height of 140 centimeters. The area of the table was carefully considered to provide the user with as much space as possible without making the table too large. Extensions can be utilized if necessary. The height raising mechanism of the table will be simple rack and pinion mechanisms. A segment of the table can be converted into a sloped section for writing purposes, providing the earlier mentioned benefits. The first layer of the tabletop can be raised by the servos, pulling up the second layer. This is of course adjustable, and the sloped section will be incorporated into both layers. The extension will be on the side with dimensions 30 by 60 centimeters. The phone drawer will be where the user places the phone to minimize distractions, and a timetable display will aid the user in time management. An ESP32 Arduino will be used only for this prototype, while the actual product will have a scaled-up component. Thank you for listening.